A week ago, Google released an announcement and published a paper about their new quantum chip. And today, a friend of mine told me that she had seen in the news that they were going to break cryptography with this new quantum chip. I thought it was very funny, and I started Googling it, and I saw a bunch of very interesting headlines. So I just wanted to give you my humble opinion of what this announcement really means. So if we look at the actual announcement, Google's blog post, we see that they claim to have two major achievements. The second one, which I think is the one that's been creating all of these headlines, says that this chip performs a standard benchmark computation in under 5 minutes that would take one of today's faster supercomputers 10 septillion years. This means 10 to the 25 years, so like a super long time, longer than the age of the universe. So totally unachievable by classical computers. Okay, but I think that the key word, the important word or words here are benchmark computation. This means that they claim that they have proven that a quantum computer can perform a task faster than a classical computer, but actually this task is not useful. Like there's no actual problem that can be solved, like real life problem that can be solved by solving this task. So they haven't proven that quantum is useful compared to classical, or that can perform a task that can solve a useful problem, faster than a classical computer. So why would they even care to show this? Well, they claim that this task is the most natural task for a quantum computer to solve, so that if you want to prove quantum utility, quantum advantage, that a quantum computer is better than classical computer, you have to start with this task. And then you can go to other tasks that will hopefully be more useful. But they don't actually show these other tasks. They just focus on this one. But they say that it's like the first step for achieving this quantum advantage. Okay. And also this is based on their assumption and estimation of what it would take a classical computer to solve this. But you never know if you can come up with a clever or faster algorithm, classical algorithm that can reduce this 10 septillion times years to, I don't know, minutes or hours or whatever. Now, the second achievement is about quantum error correction. And I think this is a really groundbreaking and important idea of this announcement. So quantum computers are made of qubits. And these qubits are what we call noisy. This means that as you're performing a computation, errors will appear in your computation. And these errors will get so big that they will eat up all the useful information about your algorithm and just end up with noise. So in order to correct for this problem, even back in the 90s, scientists thought about strategies which consist of using more qubits to try to detect and correct these errors in real time, so that you would correct these errors and then end up with useful quantum information. Right, but the problem here is that you would use extra qubits to detect and correct the errors, but these extra qubits would also be noisy. So they would also add noise to the quantum computer. So even though these algorithms worked in theory, when scientists try to build these error correction techniques to mitigate noise, they would end up adding more noise into the quantum computer because they would use extra qubits that would add extra noise and that would not be able to actually correct for these errors. But here, Google, with this new quantum chip, they showed the first possible quantum computing strategy to correct those errors in real time. So even though this Google quantum chip is not going to break cryptography tomorrow or really do any super useful computation tomorrow, it is a fundamental piece to build large-scale quantum computers, and I think it will end up being very, very important to build these fault-tolerant quantum computers.